So hi everyone, my name is Shivam Bohra. Welcome to the official channel of CodeChef. In this series, we'll solve some really fun problems based on recursion and backtracking. The difficulty level of these problems would be from cakewalk till easy, and the prerequisite for this particular course is the basic idea on recursion. So the problem statement says that we are given n number of weights a1, a2, a3 and so on till an. We have to make two groups from these weights. We have to make two groups from this array such that the difference of total weights, of these two groups is minimum, and hence we have to print this difference. So we are given this array. Using this array of weights, we have to make two groups, and we have to make sure that the difference of total weights of these two groups is minimum, right? Hence, we have to print this minimum difference. So let's say n is 5, and these are the array elements, or these are the weights that we have. So we have 5 weights over here, 2, 3, 1, 4, and 7. Now using these weights, we have to form two groups such that the difference of, or the sum of, or the difference of sum of these two groups is minimum, right? So I'll take 2, 3, and 4, and I'll place it in one group. So 2, 3, and 4 are in the first group. I'll take 1 and 7, and I'll write it inside the second group. So 1 and 7 are inside the second group. The total weight, or the sum of this group, is 2 plus 3 plus 4, which is 5 plus 4, which is 9. The sum of this second group is 1 plus 7, which is 8. The difference of these two, 9 and 8, is 1. And this one is also the minimum difference that we can achieve using this array, right? Hence, 1, which is the difference of the total weights of both the groups, is also the answer in this case, right? Now let's look at the constraints. Now over here, n is at max 20, right? And the size of these array elements could be up to 10 to the power 9. Now, n could be extremely small in this case. So this gives us a hint that we might have to use an exponential algorithm to solve this problem, right? Or in other words, we might have to go with a 2 to the power n algorithm to solve this question. So now let us move on to the approach. So here we have 4 weights, 1, 3, 5, and 4. And initially, both the groups are empty, right? So initially, the sum of both the groups is 0. Now, for each of these weights, we have two choices. That is, either we can add the weight on the left hand side or with the very first group, or I can add this weight with the second group, right? That is, either I can add the weight with the first group or I can add it with the second group. So for this one, I have two choices. I can either add it with the first group or I can add it with the second group, right? So if I add this one with the first group, the sum of the very first group would be 1 and the sum of the second group would be 0. And similarly, if I add it with the second group, I'll have 0, 1, right? So I have used 1 till this moment, right? So I have used 1 over here. Right? Now we have this 3. So now I have to use this 3, right? So again, for this 3, I have two choices. That is, either I can add this 3 with the very first group or I can add it with the very second group, right? So if I add this 3 with the first group, so now the total weight of the first group would be 1 plus this 3. So it would be 4. And if I add this 3 with the second group, so the weight of the second group was 0. So 0 plus 3 is 3. So now the weight of the second group is 3. So now, using this 3, I formed these two groups, 4, 0 and 1, 3, right? And at this level, we used 3, right? Now, again, we have the next element as 5. So again, for 5, we have two choices. Either we can add it with the first group or with the second group. So I can add 5 with 4 to form 9, comma 0, and I can add 5 with this 0 to form 5. So this way we will have 4, comma 5, and at this level I used 5, right? So now the only element left is 4. So again, with this 9, comma 0, I'll use 4 on both the sides. So I'll have 13, comma 0 and 9, comma 4, right? And at this level, I used 4. Now, this 13, comma 0 and 9, comma 4 is the very last level because we have used we have used all the array elements. So now we simply have to find the difference of both the groups. So the difference of group 1 and group 2 over here is 13. The difference of 9, comma 4 is 5, right? Similarly, using this second group that we had over here, similarly, let's try to fill it. So with 4, comma 5, the only element that I'm left with is 4 because this 4, comma 5 is formed using 1, 3, and 5. So now we have to use 4. So again, I'll simply add 4. I'll simply add this 4 on both the sides. So now we have 8, comma 5 and 4, comma 9. I'll simply rewrite the difference over here. So the difference was 13. Over here, the difference was 9, comma 4, which is 5. The difference of 8, comma 5 is 3. The difference of 4, comma 9 is again 5. Similarly, let's try to fill this up. So I have filled this up. Now over here, in the very last row, we can see that we have differences 13, 5, 3, 5, 7, 1, 3, 11, 11, 3, 1, 7, 5, 3, 5, and 13, right? Now, which out of all these is the minimum that we have? So we have 1 over here and 1 over here, which are the minimum that we have. So 1 is the minimum difference. 1 is the minimum difference that can be possible over here. Hence, 1 would be the answer in this case, right? Now over here, let's observe a few things. So let me quickly draw a line over here. Now we can see that I have 11 over here and 11 over here, right? I have 3 on the left hand side and 3 on the right hand side, right? Then I have 1 and 1. Then I have 7 and 7, right? Then I have 5 and 5. Then 3, 3, 5, 5, and 13, comma 13, right? Also, we have 1, comma 3, 3, comma 1, 4, comma 0, 0, comma 4, 6, 3, 3, 6, and so on, right? So this structure on the left hand side is the exact mirror image of the structure on the right hand side, right? So I can simply discard one out of these two. So let me discard this part, and using only this particular part, I can simply get this minimum value because over here I am simply repeating all these values that I have, right? So let's just discard this remaining portion. Let's just simply use this 1, comma 0 to find or to get all the possible values that we can achieve, right? Now using recursion, I'll try to go through all these possible cases and I'll try to get the minimum possible difference that I can achieve, right? So firstly, if we are at the very last level, that is if we are at 13, 0, 9, 4, 8, 5, 4, 9, or so on. If we are at this very last level, then in that case, the value of this function or the value returned by this function would simply be the difference of these two values, right? 13, 0. So over here, what is the difference of 13 and 0? The difference is 13. So this would return 13. What is the difference of 9, 4? It is 5. So this would return 5. Similarly, the difference of 8, 5 is 3. So this would return 3. 4, 9 is 5. 10, 3 is 7. 1, 3, 11, right? So these are the values that are returned by their respective functions, right? Now, so for this 9, 0, I have two values that I can get using this 9, 0. I can either get 13 13 or I can get 5, right? But at the very end, I have to find the minimum possible difference, right? So which out of these two, 13 and 5, which out of these two is smaller, or which out of these two is minimum? So 5 over here is minimum. So this 9 comma 0 would return this 5, right? Which is the minimum value. So this 9 comma 0 would return the minimum value, which is 5. Similarly, for 4 comma 5, we have 3 comma 5. So which out of these two is smaller? So 3 is smaller. So this would return 3. Then we have 7 comma 1. So this would return 1. Then we have 3 comma 11. So this would return 11, right? Not 11, 3. So this would return 3. So 5 and 3, so which is minimum? 3 is minimum, so it would return 3. 1 comma 3, so which is minimum? 1 is minimum, so this would return 1. 3 comma 1, so which is minimum? 1 is minimum, so the final answer given by this 1 comma 0 would be 1, which is also the answer in this case, right? So recursively, we'll try to find out this 1, right? So using this 1 comma 0, we have to call this 4 comma 0. But this time, since we are using this function fun, so we'll have a bit more extra parameters, right? So this function fun has 5 parameters: array name, sum1, s1, then sum2, s2, then I, which is the index of the next element that has to be added, and n, which is the size of the array, right? So n over here is 4. Initially, we have added this 1 with the very first group. So initially ARR of 0 has been added with S1. Then S2, which is the second group, is empty, so its value is 0. Then the next element that has to be added is at index 1. So 0, 1, 2, 3. So 1, or at index 1 we have 3, which is the next element that has to be added. And then we have 4, right, which is the size of this array, right? So firstly I need to add this 3. I need to add this 3 with the very first group. So I need to add this 3 with the very first group. So I'll simply add this ARR of I with S1. So let me write it as, for the left call, I'll simply write fun of ARR of, or I'll simply write fun ARR. S1, or the sum of the first group, would now be S1 plus ARR of I, the element that has to be added, comma. S2 would remain as it is, comma. Now we have added this next element at I1. So the next element that has to be added now is at I plus 1, comma. N would remain as it is, right? So now after adding this 3, now array ARR would remain as it is. The sum 1 would now be incremented from 1 to 4 because we have added this 3. So now we have rewritten S1 as S1 plus ARR of I. S2 would remain as it is, so S2 would remain 0. Now, since we have added the element at ARR of 1, the next element to be added would be at ARR of 2. So now I is also incremented, so now I has become 2. So I, instead of I have called I plus 1, and N, which is the size of the array, would remain as it is, right? Similarly, I'll again write the same pattern. I'll again add ARR of I with S1. So now ARR of I, which is 5. So 5 is now added with the first group. So the first group is 4. So now 4 plus 5 would be 9, right? Second group would remain as it is, 0. And I would be incremented from 2 to 3, right? Because the next element that has to be added is now at index 3. So after this, the size of the array would remain 4, right? So again, I'll add ARR of 3 with this sum 1. So ARR of 3 is 4. So I'll add 4 to this 3. So now we have 13. Sum 2 would remain as it is. I would now be incremented by 1. So I would become 4, right? And 4, which is the size of the array, would remain as it is, right? Now, we have added all the array elements, right? So now we are at the very last level. So at the very end, when I is equals to n, then it means that we are at the very last level. So we simply have to return the difference of these two sum. So if I equals to n, n, then we simply have to return difference of s1 comma s2, right? So let me rewrite it over here. If we are at the very last level, that is if I is equals to n, then in that case we simply have to return the difference of s1 comma s2, right? The difference of both the sums. Otherwise, firstly I need to calculate the left sum of this function fun. So the left of this function fun would be fun of, it would be fun of ARR, fun of ARR. I'll add this ARR of I with S1. So for left side, I'll add ARR of I plus S1, comma, S2 would remain as it is. I would now be incremented by 1. So I, instead of I have written I plus 1, and N would remain as it is, right? Similarly, for right, fun would be ARR. Now this time S1 would remain as it is. Instead of S2, I'll write S2 plus ARR of I, comma, I would now again be incremented by 1, I plus 1 and N, right? So for left, I'll add ARR of I with S1. For right, I'll add ARR of I with S2, right? And since we have calculated this left and right, after this, I'll simply return the minimum of left and right? And curly braces closed, right? So this completes the function. That is, if I equals to n, then we simply have to return the difference. Otherwise, we'll calculate the left of this function, the right of this function, the left value of this function, the right value of this function, and we'll simply return the minimum of these two values, left and right? So minimum over here is 5. So we'll simply return the minimum over here, right? So let's write the code for this. So let's move on to the code. So firstly, I'll input n, which is the size of the array. Then I'll create a array of size 20 because we can have at most 20 elements. Then I'll simply input these n elements inside this array ARR. And over here, I'll simply call this function fun, having arguments array name. Over here, ARR is simply a reference to the array. Then sum1 would simply store the 0th element of this array. Sum2 would be initially empty, so I have written 0 as the sum of this array. The next element that has to be added to any of these two groups would be at index 1, which is the second element of the array. And the size of this array would be n, right? So we are simply calling this function fun over here. Now, this function fun would have array a sum1 s1 for the sum1 and s2 for sum2, right? I, which is simply the next element or the index of the next element that has to be added, and n is the size of the array, right? So if I equals to n, if we are at the very last element, then we'll simply find the difference of both the sum, right? So for the difference, I have written ABS, which is the absolute value of sum1 and minus sum2. So absolute value of this subtraction would give us the difference of this sum, and I'll simply get the left value and the right value by simply calling the function fun. For left, I'll simply add ARR of I with S1. For right, I'll simply add ARR of A of I with S2. And in both the cases, I'll increment the value of I. And at the very end, I'll simply return the minimum of left and right? So let me quickly run this code. So over here, I have the same 4 elements, 1, 3, 5, and 4. So let me run this code. So over here we can see that I got 1, which is the correct answer, right?